Hello, my lovely friend. Are you ready to do this new problem together? So let's get started. Here we are going to find the area of trapezoid. I only have this side, the height of trapezoid, and this side. I try to use some rule to find two base because we know the area of trapezoid equals the sum of the two base that they are parallel. So A plus B and then divided by 2 times height, which we have here is 4. So I have to find this base and this base. First of all, we know I have a rule that says the tangent from the external point to the circle are equal in length. So if I label here A, the tangent from A to the circle would be equal in length. That means this, if I get here, this length x, so this length would be x as well. Again, I try to use this rule that says the tangent from the external point. This time I get this point to label this point B. The tangent from B to the circle, that B is the external point, are equal in length. So if I get here y, this segment would be y as well. So this side from here to here would be y, and from here to here would be y. We see the height of this trapezoid is 4, and the height is what's the circle is yes, diameter of the circle. And we know the diameter of the circle is twice the radius. So the radius here is 2. If I get it 2, so this side would be 2 as well, and this side would be 2. So to find this 2 base is enough to find the x and y. First of all, I have an equation which say x plus y gives me the length of this side, which is 5. So I have x plus y equals 5. Okay? And if I create, let me draw a diameter of this circle. Okay, I find it. Now, if I say this triangle, that I label here, this side would be ABC, the triangle ABC, which is right angle triangle. If I draw it, y equals this length BC plus x, which I create here rectangle, so y equals x plus CB, the length of CB. It's enough to find the length of CB. CB is the base of the right angle triangle, which I have the hypotenuse of it, which is 5 here. Let me show you for this right angle triangle, which is here. Okay, for this right angle triangle, 5 is hypotenuse, and this side would be 4. So I can use a Pythagoras theorem to find BC. So I say BC to the power of 2 plus this side to the power of 2, that means 4 to the power of 2, which gives me 16, equals hypotenuse to the power of 2, which gives me 25. I tried to use Pythagoras theorem. So Pythagoras theorem, I bring 16 to the right side, so BC to the power of 2 equals 9. I take a root from both sides, so BC would be 3. I never, for any length, get a negative number because negative I can't get for a length, for a side. So I only get positive 3. So BC equals positive 3. I substitute the value of BC in the step 2 that I find. So y equals x plus 3. Okay, I go back to the first step that I can substitute x plus 3 instead of y here. So I say x plus, instead of y, I am going to put x plus 3. X plus 3 equals 5. Bring 3 to the right side, 2x would be 2. 2x equals 2. So x equals 1. If I get x equals 1, so y equals 5. Oh, we find x and y. So I could find the both base of this trapezoid. X equals 1. So this length would be 3. Let me again erase here. So this base would be 3. And y equals 4. If I get x equals 1, 1 plus 3 gives me 4. So y equals 4. So if I put y 4, this side would be 2 plus 4 gives me 6. Anyway, I can find the area of trapezoid. The area of trapezoid would be 6 plus 3 divided by 2 times the height, which is here 4. So I can simplify this 4 with this 2, gives me 2. 6 plus 3 gives me 9. 9 times 2 gives me 18. So 18 square unit would be the area of this trapezoid. I hope you really enjoyed. If you enjoyed, subscribe, share with your friends, and stay tuned. I will see you in the next new problems. Bye bye for now.